This video reviews the risks of static electricity and mitigation of those risks through proper grounding and bonding. Grounding and bonding protect against electrical hazards and the buildup of static electricity that can cause shocks, ignition, fire, or explosions. Static electricity is a type of electrical charge that builds up in materials when they rub against each other. It's called static because the charges stay in one place instead of equalizing between points or moving to ground. Static charge can build up on conductive and non-conductive materials, like metal and plastic pipe. When objects with high static potential are in close proximity or touch a lower potential object, the charge is rapidly transferred or discharged, creating a sudden electric current. Static discharge can occur as a shock or spark. The human body can also hold a small static potential. The energy released in a static discharge from the human body is 100 times more than the energy required to ignite a flammable vapor or trigger an explosion. Grounding is a way to control the buildup of electrical charge. It provides a safe path for electrical currents to flow into the ground, preventing the grounded object from developing a dangerous static potential. Bonding is connecting objects together to allow the charges to distribute evenly between the objects and ensure they are at the same electrical potential or voltage. When the potential is equal between objects, the risk of static discharge is eliminated. Electrical and non-electrical equipment should be grounded and bonded if they can pose a shock, fire, or explosion hazard. Where can static charge pose a risk in the energy industry? Examples include machinery with moving parts, temporary equipment, movement of gases, fluids, or solids. However, dangerous static potential can build anywhere in the energy industry. That is why proper grounding and bonding is needed to mitigate the risk of shock, ignition, and explosion. What does good grounding and bonding look like? Use designated points for grounding and bonding. These points should be clear from paint and rust, which would decrease or eliminate effectiveness. Ensure all electrical connections are solid and secure. Use conductive instead of non-conductive hoses. Check for damage of the grounding and bonding components. Confirm electrical continuity of grounding and bonding systems, or consider using an integrated engineered system that prevents product movement in the absence of an adequate ground. Protect yourself and your coworkers from shocks, fires, or explosions caused by static. At your site, where is the potential for static electricity buildup? What controls do you have in place to reduce the risks of static electricity, and are they sufficient? Ask your supervisor about grounding and bonding at your site. Energy Safety Canada is the national safety association for Canada's energy industry.